So I've talked a lot about the differences of selling a product as a liquid or selling a product as a gas many times throughout this presentation, and that's simply just because in the at least the current price environment and probably the price environment we've been having since the beginning of the oil industry have always favored liquids versus gas, and that's why we like oil reservoirs. We like to get as much condensate produced at surface because the value of those products are at least in a general sense, and 99.99999 probably percent of the time worth much more money than gas. And just to exemplify that, I just want to do a quick and simple calculation of let's say isobutane. Okay, so isobutane, that's I C4. And the thought process is, okay, we have this molecule or this component, and we have two different scenarios. Either that this component, which is a light intermediate, can go either into the liquid phase or the vapor phase. So how much money could we get if we optimize something such that we get isobutane into the liquid phase and we sell it as liquid? How much better is that? And that calculation is fairly straightforward. We can start with oil. So we just create some kind of basis. So let's say we have okay, let's say we have just 1 mole of isobutane, and I see now that I'm not a very good writer, but that we can work on that. Okay, I can become better on that. So that should be fine. But that's the basis we have, and we start with the theory. Let's say we actually get this into the liquid phase. Then we know that the formula for this is simply just the molecular weight of isobutane times the number of moles times the density. The reference that we can use just to get these properties for isobutane is the appendix A in the SB phase behavior monograph by Whitson and Brulé. And that's where we can, for instance, get molecular weight and density for isobutane. We can take those values from that table, and we know that the molecular weight of isobutane is 58 pounds per pound mole, and we can multiply that with 1 pound mole. This is kind of just a units game. And then the density of that, if in the liquid phase, we know that's also in that table, and the value for that is 35.1 pounds per feet. Okay, and if we do the math here, we come to a number that's 1.66 scuffs. Again, converting this to standard more stock tank barrels, we get a value that's around 0.296 barrels. Or since this is stock tank barrels, this is sellable stock tank barrels, we have to be consistent and we use large STB. Sorry about that. Then doing the same, like the alternative is that this is in the gas phase. Then we know from the real gas law, nRT over P. Again, just filling out this formula straight out of the box, LBM mole times the R. The R is also given in the monograph or just online in field units, which is then PSI A feet squared per Rankine. It has some weird units, this thing. But the most important thing is that the units add up, and then we divide this simply by 14.7 P by A, and we think that's actually, because this is at standard conditions, this is standard conditions. At standard conditions, we assume that C is equal to 1 from the real gas law, so that's why it's not accounted for here. And we get this number, which is 379.375, that I guess a lot of you that have worked with this a lot as a very, very recognizable number. And we can convert this into a unit that makes sense from a price point of view, and we can see that this is around around 0.4 about MCF. Okay. And then we need to assume a couple of prices. So the idea about this exercise was that, okay, the oil value, so essentially in terms of dollars, that's what we wanted to care about, over the gas value in dollars. That particular ratio is what we would like to determine here. And to do that, we have the oil value. Then we need to, okay, what's the oil volume that we can get from 1 pound mole? That's given right here. So that's 0.296 barrels. And then we have to pick some kind of oil price, and I'll just pick 50 50 USDs per barrel. And then we'll simply just divide that by the gas value, which will be 0.379 MCF. Then we pick just some the gas number. At least this is a good number in the States, many places right now, which is 2 USDs per MCF, and we're then left with a ratio that's around 19.5. Good. Sorry for the writing, by the way.